But good afternoon, everyone, and good morning to the colleagues attending outside of Finland. So I see some PARC colleagues also attending, so good morning to you. And welcome to this seminar, which is targeting PARC and more specifically the rapid response mechanism, addressing the increase in mono-n-hexyl phthalate exposure in Europe. So this science seminar is part of a series of online seminars that we are planning to organize this year. It is targeting scientific content, so we invite the researchers to come online and present the project that are relevant for regulatory activities. Those topics can target either human health or environmental issues, and the aim of those seminars are to discuss the science, of course, but also the regulatory relevance and the regulatory uptakes of the results within our mandate. So just a brief introduction of the scope of the seminar of today. So it's targeting the rapid response mechanism, which is a mechanism that has been developed on the PARC in order to manage the possibility of incorporating new urgent requests in the PARC work program. So an urgent request is anything that can deal with either a lack of specific information or knowledge or addressing an urgent new issues. It can involve a short-term policy or regulatory needs at the European and or the national level. Briefly, how it works. It's once the request is submitted, PARC has 45 days to assess the eligibility and the feasibility criteria of the request. And if this request is accepted, it enters the PARC workflow and it becomes a PARC project. So concretely, last year, EEA and ECHA have activated this mechanism for a specific phthalate, so mono-n-hexyl phthalate. And this came from some new data indicating a serious increase of this phthalate concentration in the urine of the children and also the general population. It was based on a monitoring done in Germany, but also in Denmark in the young men population. So in addition of this increase, the uncertainties are what is the extent of this exposure and the origin of the exposure to this phthalate. So EEA and ECHA has decided to submit a request to be addressed by PARC. And it has been accepted and it had become a project. And the outcome of this project that will be presented by Till today can support the future restriction on phthalates that will come to ECHA. And now I will give the floor to Dr. Till Weber. So Dr. Till Weber works at the German Environmental Agency. He is focusing more on the human biomonitoring. He is a chemist, and in PARC, he is the project manager of this new project that has been developed following the rapid response mechanism that we have submitted. So now, Till, the floor is yours, and I will stop sharing.
So yeah, thanks also to you all for the opportunity to speak in front of you. Yeah. As Safia already told you guys, the topic will be the rapid response mechanism and the first results from PARC, from the project generated in PARC, because as such, the project that now came out of the rapid response mechanism will continue throughout the whole project time of PARC. So not all of the project results will be I will be able to present today, because there are some really interesting things to come in the future. So let's see. Yeah, just a quick introduction so that everyone here is on the same page regarding the substances and the data that led to the invocation of the rapid response mechanism. I don't think I have to go too far into details, but we will talk now about a bit of the group of the phthalates, which are plasticizers used in plastic, so used as solvents, and also to make plastic more tangible. And they are a highly regulated group because some of the phthalates, which were mainly in use in the late 90s, were already identified as endocrine disruptors and as reprotoxic. So the picture we usually see is that we have very highly regulated compounds. Here, for example, the d-ethyl-hexyl phthalate, where we can see a vast decline in exposure. Here is data from the Environmental Specimen Bank in Germany, and on the other hand, of the National Health and Nutrition Examination Survey in the US. So quite complementary data over the world. And on the other hand, incline of substitute plasticizers. So this is the picture we are currently used to work with. So the use of phthalates declines, and thus the exposure, at least in through consumer products, also declines as well. So we were quite baffled, let's say it, when we realized in Germany at the end of 23 and the beginning of 24, when we saw these exposure towards mono-n-hexyl phthalate, so in the following MN-hexP in these slides. What we saw were, as Safia already told you, some data in kindergarten children, so children aged 2 to 6 years. On the one hand, as you see here on the right, the rise in detection frequency, but also a rise in the general exposure concentration, so nearly a 10-fold increase in these 4 to 5 years in the 95th percentile. And in parallel, we were working on the representative data in Germany. This was preliminary data, so around 500. It was like a third of the planned participants, where we could see an exposure of around a third of the samples we evaluated. After some research, we also found some data from the Danish population. You will see here quite higher numbers of detection, but this is mainly because the evaluation is done based on a really low LOD. So the exposure ranges were quite the same. And so since the potential and the most likely parent compound, because we are talking about the measurement of the mono-n-hexyl phthalate, so a metabolite, usually, so it means you lose one of the side chains of the phthalate here. So the most likely parent compound, the d-n-hexyl phthalate, is a known reprotoxicant, is not registered under REACH, so why should anybody use it? So we wouldn't expect any exposure, and we already used the new analytical method, which led us to being able to even detect it some years before, and we didn't find any data on it. So we were quite surprised, and so shared this data, and thus the rapid response mechanism was activated. What is important, at least on this slide number 4, you will see in the following slides that it gets a bit less important, in my opinion at least, is that there are potentially other chemical compounds that could also lead to the detected metabolite, because the side chain you lose in the process of metabolism could be any kind of side chain, and you would be left with the mono-n-hexyl phthalate. So at that point in time, we were thinking there could be some different parent compounds, and this is especially important from the toxicology perspective, the measured compound is also the toxic relevant compound. So for the toxic evaluation, the exposure we see to mono-n-hexyl phthalate is for us the same as the exposure to d-n-hexyl phthalate. So quite an unexpected substance where we didn't really know where it came from. So the rapid response mechanism got activated, and I'll start to explain, let's say, the rapidness of the rapid response mechanism. It has a built-in mechanism of the PARC partnership for the assessment of risk from chemicals is, as Safia already told you, to be able, for at least for the agencies, to communicate the urgent need and for information or for the filling of data gaps. And the rapidness of this response in like the broad concept of these kind of big projects and agency-related works is the answer duration of 45 days. So as you can see, when the request started, so the general request was done by the EEA and ECHA in co-authorship. It was sent to the PARC representatives in February. Then it started, as Safia already told you, with the checking of the eligibility. So is the topic related to the general scope of PARC? The organization bodies of PARC were informed. So we have the stakeholder forum, the governing board, and the management board. And after it was deemed eligible, the PARC expert, there was like a call for PARC experts who were related to this general topic. A working group was gathered and the request was assessed. So again, like the main questions of the request was, where does this exposure come from and how does the exposure situation in Europe look like? Because up till now we only had German and data from Germany and data from Denmark. And on the other hand, the question, why do we find this? What's the exposure source? Because it shouldn't be there. The working group assessed the information in April then that year. We had members of all the different related tasks. So we have a big work package, the work package 4 considering human and environmental monitoring. So we had experts from these groups, experts for analytical methods, because here, although like the phthalates as a chemical group are fairly well known and also researched quite a bit, the analytical method for this compound, for this metabolite, was, as far as we know, only established in 3 European laboratories yet, and also some colleagues who worked on modeling, so source to dose responses. And the available information was discussed, also current developments, which I will get into a little bit later, and a response document was formulated, which laid out like the capacity of PARC to respond. And again, there, as Safia already told you, on the one hand, PARC built a new project around this topic. On the other hand, it was quite nicely done to implement the topic of this mono-hexyl phthalate exposure into different already ongoing projects. So a kind of parallel approach, interestingly, because it fits quite nicely into the scope of PARC. There were already so many like actions happening that they didn't have to implement a complete new action, but there could be just work added into there. So to skip the part or to get now into the current developments, because I cannot quite directly start what PARC did on May 16th or agreed to do on May 16th, because as it sometimes happens, the science works faster than the agencies can work behind them, or just like the humoristic approach. But since this topic got quite a lot of attention in Germany, we already had to work and on this topic in January, February, and March, and so many things happened. And so in the next slides, I will show you the update on the gathered information on the one hand between January and May 24, but already since now it's already March 25, and all the data will be like congealed also in this rapid response mechanism project, like what is known at the current moment, so that I don't have to like incrementally show you the data, for example, from the JERIS study. So what changed? What did we already know? We looked further into the JERIS data, and this is like already a combination of what is now the final data set in 2025, but which was already available data in part in January and February. As I told you, we started with the N of 500. Now the complete data set is analyzed, and we have data of 1,600 adults, still around a third above the LOQ. And we additionally looked into old biobank samples of the JERIS-5 studies concerning children and adolescents in Germany, and saw there as well approximately a third or a fourth of the participants above LOQ. What we then saw regarding our additional data, so the questionnaire data we always gather complementary in these HBM studies, was a seasonal pattern of exposure, and in correlation with this, a strong association of the MNXP exposure towards cosmetics use, and there especially to use of sunscreen. So there were exposure assessments questionnaires which asked the question, when did you use sunscreen in the last weeks, in the last days? And thus we could correlate like people who used sunscreen in a few days ago had the higher chance of exposure to this substance. The same could be shown in the ECHA study, so for the children aged 2 to 6 years. So we had like a first target in mind regarding the potential exposure source. Again, here the update for the ECHA study, there is already has been the next round of exposure assessments and of sampling. Again, 250 children, and this data, or at least like the press release about this data, was in end of February this year. So we see that we are quite in a similar range of detection frequency, so a little decline from 61% to 55%. But we see already now 2 samples of the children above the HbM1 value, so the exposure itself seems to be higher currently, at least in this population. So a little bit of the focus of sunscreen, and as it would have it, a bit through lucky circumstance, but also through, like, as always, the good work of all the people involved. We found patents of an associated UV filter, the diethylamino hydroxybenzoyl benzoate, as always with chemicals, is a really long name. So DHHB in the following. A little bit of, and we found actually 2 different patents, and the one needs a little bit of chemical knowledge to see if you have like the phthalate anhydride in a solution of N-hexanol, that you could potentially expect a contamination with hexyl phthalate. Easily enough, there is a second patent which especially talks about a cleanup of this UV filter after synthesis because of especially this impurity. So we kind of knew direction where to go. Generally, considering like the regulation around this, I don't know how firm you guys are considering the cosmetics regulations. So the impurities themselves are allowed if they are technically unavoidable up to a certain degree. But so it's not unsuspected to have these contaminations. But so here we had like the next puzzle piece to find the potential source. In combination with the local federal state agencies in Germany, which are responsible for product safety, there was a new data set, and here already available in the beginning of 24. The screening of sunscreen products from just from shelves in Germany, where you can see that they found 40 sunscreens using this UV filter and around 50% contaminated in the final product with measurable amounts of this hexyl phthalate. What is especially important here, because I said it already, if it's technically unavoidable, it's allowed. It seems to be avoidable, as you can see in this data set, because there's no strict relation between the blue line here, so the amount of UV filter used, and the amount of exposure. So you have products with high amounts of UV filter and no contamination of DNXP. There's also already from this year an updated data set of the same office available, a little bit more of the products tested, and in general correlation, a little bit less contaminated product using the UV filter. But I won't say that this is already an effect we can see. Although the industry already said they want to try to lessen the amount of contamination, because I don't think that the number of samples is big enough to conclude this. And especially interesting here, as you can see on the last sentence here, the contamination we found are higher than the contaminations from the year before. So less contamination in the number of samples, but higher contamination in the extremes. To prove the point in the end, there are some analyses looking into stock material, so not the final product, but just the stock material of the UV filter, where there were the expected contamination as shown in the patent, so around the 150 ppm. And additionally, where we are quite fond of, we were able to also publish some data, because in combination with the invention of a new analytical method regarding this UV filter, we had some exposure data where we could then correlate that this stock material we used was also contaminated with the hexyl phthalate, and thus we could now publish data on the exposure. And in general, the general fact is we could show that exposure towards these contaminated sunscreens lead to measurable amounts of the mono-n-hexyl phthalate in the urine of the participants. So quite nicely already a logical line of reasoning that the exposure source seems to be this UV filter. Considering regulation, the cosmetics for the use of the UV filters, the Scientific Committee of the Consumer Safety is responsible, and they got the mandate, I think, in November or December last year to reevaluate this UV filter. Since the contamination itself wasn't included in the original proposal. And currently there's online, since I think also last month, the preliminary opinion for comments, where the SCCS proposes a limit of lower or up to 1 ppm because of the available data that the contamination is that it is technically feasible to have this substance without contamination. So a whole lot of this was of the basis data of this was already available in April, in March and April 24. So we were able, considering the general time frame of the rapid response mechanism, to already share this data in the PARC expert group. So the decisions made in the expert group, what to implement, so which topic to implement in PARC itself, was also based mostly on these data, which were additionally to the original request from EEA and ECHA. So, important part here, source mitigation already seems to be on its way. So this is a good effect of all the work that has been done already. So, proposed actions in PARC. To get back to the general questions we had that were asked in the rapid response mechanism, I start with the second one because all the slides I showed you now regard mainly the source of exposure. So we agreed in the expert group that we will focus on the European level also on this UV filter to see on the one hand how far the possibility of exposure spreads. So the colleagues working in the source to dose department tasks are going to do a literature and database screening for the use of this UV filter in cosmetics and products, which is currently ongoing. So I'm awaiting the data, like I think tomorrow or the day after. Sadly, I couldn't implement them here already. And as it's like usual to do for the phthalates, we will also look a little bit into indoor dust sampling, so samples from the indoor environment, because the dust samples are usually a sink for indoor environmental phthalate exposure. So they are like considered semi-volatile compounds, and so they will enter the dust through migration, and so this is usually something you can nicely correlate, and we are really interested to see what we will see in these samples, because PARC is has the complete approach to not only look into products but also to look into environmental exposure, human exposure, so to get the complete picture together. This is short term because we will have the data for the literature search, as I said, like I think this week, sadly not today. And the dust sampling it's about biobank samples, so the sampling is already done. The analysis data will be there at the end of 2025, so this year. On the long term, and this is the part where it's not a new project in PARC, but an additional topic in ongoing projects. The DNXP and the MNXP will be part of two screening projects, which is one on endocrine disruptors, so suspect screening in environmental and I think also human samples. I'm not quite sure here yet, sorry. And a project about non-food exposure sources. And so this is an ongoing project which will also be like in parallel to the human biomonitoring studies in PARC. So this data will also will be available the latest at the end of PARC, but also like the earliest, like a year before when the studies are finalized. So we knew a lot about the source already, so this is more like trying to get more into the specifics and also to see if the general range of products are the same in Europe as they are in Germany. The other question, so generally the first question is, what about the exposure in Europe? Because I only showed you now German data, and there is another data set of the Danish population currently being published, as far as I know. So considering the European exposure, the expert group proposed 3 short-term possibilities, because again, when we want to know about the exposure in Europe, you need European samples. So, and this is like to at least relatively or in part relativize the name of the rapid response mechanism. So how rapid can we generate data? We can really rapidly formulate an answer document where we talk about what we will do. But now the question, how fast can we really derive data? So on the short term, is there any unpublished data, which is always like a really important question to ask, sitting on a table with many experts, because not all of the agencies are able to publish all of their data, or in some parts only publish them still only on a national level. So we looked into unpublished data about the hexyl phthalate. Again, the laboratories currently able to measure them are quite scarce. So there were only 2 data sets available from Spain and Italy, which show a quite similar exposure as the Danish population. For the Spain sample, I didn't actually have a look into the Italian sample yet, and this fits quite nicely because the Spanish samples were analyzed by the Danish laboratory. Then we looked into the potential reintegration of old data, again on the basis of that there were measurements in the last years by the laboratories who are able to evaluate the substance, but in part there is the possibility that you send your samples to the laboratory and say, I want like these 10 substances to be measured. And so you only have the results for the 10 substances, but the measurement itself included some other substances. And here we found from the HBM4EU study, 3 data sets which were accessible for reintegration. So the laboratory is looking into the already available data and is reintegrating these for MNXP. Again, here we already have the data available. I do not present it here because I don't have like the specifics, but for a short update, it's like it looks the same as in Germany in the earlier years. In the earlier data we have from Germany, all the 3 data sets, as far as I know, are not from the summer months. So we only have exposure of around like 5 to 10% of the analyzed samples. And this is what we currently expect in the non-summer, non-sunscreen use months to see. And also the data set was again in part quite old, because I think the Polish samples are the newest ones from 2020 and the samples from France are from 14 to 16. In addition, we thought about analyzing more biobank samples, but especially in combination with the effects we are seeing, which seem to imply that we have a rise of exposure in the last years, we don't see the extra value of looking into older subsets, as we can show already with the HBM4EU data sets that we don't expect really high exposure in years like prior 10 years before now. But we will have to check. There will be some data sets available on new data which will underlie this decision. So this about the short term. And yeah, as I told you already, the data sets that were already evaluated show similar exposure across Europe. So we see this exposure also in Spain, also in France, the Netherlands, and Poland. Long term here is quite obvious for people who know the work of PARC. In the work package 4 is a big part of this work package 4 is the new harmonized biomonitoring study for Europe, called the PARC General Survey or the PARC Aligned Studies, where there will be aligned sampling in the next 2 years. So starting, I think some studies already started. I only know the details for the German study. My colleagues start the sampling next month or the month after, so in May, I think. So again, how fast can you generate data? We at least need a year of sampling first to then analyze the data, the samples. And here we expect really interesting data for the whole of Europe, because we have many different countries involved in the aligned studies, so there will be a big data set. Although, and this is like the little caveat, it heavily depends on the laboratory capacities, because the timing of the request itself, of all the information gathered, was after the prioritization of substances and in PARC itself for the aligned studies. And as always, money is a big question regarding data. And so many of the studies already have contracts with respective laboratories, and we weren't able yet to see how many of them have approached laboratories from where we know that they are available and able to analyze this MNXB metabolite. But additionally, there are in PARC, there's now a project working on the harmonization of methods and implementing a little bit of quality assurance and quality control, so that the data that will be gathered on this hexyl phthalate will be validated and in a comparable amount. So we are quite looking forward to it. But just on a logical point of view, these studies just start now, so we'll need a whole year of sampling and I bet an additional year of analyzing to have the final data set. And then when the statisticians are happy with it, I think we can expect this data set in 27 and 28, so at the end of PARC, because it will be like the final HBM data set, part of the final HBM data set. So that brings me to the conclusion. I think I was a bit faster than I expected, at least. The rapid response mechanism itself, in my opinion, is a really feasible tool to communicate urgent needs and requests for incorporation in PARC and or for dissemination in PARC, because it leads to a fast utilization of the PARC expert network on a European level. And this is something which is, in my opinion, really, really valuable, because you have the possibility to have a fast approach, to have every national representative interested in the topic gather and discuss the topic and see what can be done. It gives the potential also for fast solutions. So again, for me itself, it's a little bit the running gag. You cannot expect like the rapid response to be the solution for the questions, but funnily enough, or happily enough, through the coincidences we had many national data sets which were already available to explain at least one of the questions of the request itself. On the other hand, for the long-term goals, the implementation into PARC was feasible, and so the using the rapid response mechanism just to give this input and to see that this uptake in the project is there, I think is a really, really important part and a really valuable part of this mechanism. Long-term approach has to be, it's an integration in the PARC project, so the PARC project will continue until 28. So an integration into a project cannot or has not to mean like that it is quite a fast project, or it will be prioritized for the next month or the next year. A thing that is really important for me to recognize is that all the requests are highly dependent on surrounding factors, and this is for the project itself. The status, because like in the way of prioritization, if the studies are already finished, what can I measure? And as always with the European projects, all of the work has to be co-financed, so or at least most of the work. And so as interesting as sometimes a research question is, if you do not find anyone who makes it really feasible to work on it, it would be complicated. But this is not really relevant for the rapid response mechanism this time, because I at least think wherever possible and wherever really like feasible, this topic was integrated in the PARC research questions. So different projects, different tasks will now work on this as well, and it will be part of the final PARC products. For me itself, or again for the project itself, and this is maybe doubling down on something because the agencies are involved in PARC. So I personally think this is a really valuable point of PARC in itself, but so of this tool and of the mechanism as well, we have the direct communication of the agencies and the project partners. We have the direct link to potential data that is already available, and this is a really big advantage. And just to not be the 100% positive guy here, I think this is a really big success story from the topic itself, but, and this is only a little but respecting like other requests to come, the MNXP problem fits quite nicely in the priorities PARC already had. So the phthalates themselves were a prioritized group in PARC, although like the one specific phthalate was not. So when we are talking about the capabilities of the analytical departments to now deliver data about hexyl phthalate, it's not about getting a complete new analysis going, but only like adding another metabolite, which is from the chemist's point of view already complicated enough. But so this is the success of this story highly dependent on some very interesting factors, which hopefully will align for the next request as well. But yeah, I think a really nice success story already, and this is before like the really big PARC data sets will arrive, and this will only make it more of a success, at least in my opinion. So that's from me. If you have any questions, feel free to ask. And again, thank you very much for the opportunity to present this here for you all. Thank you.
Thank you, Till. It was really clear and really interesting. Thank you for this update. Is there any question? Yeah, please.
Hi, Till.
Hi.
Hi, thanks. Thanks for the update and sharing these first data with us. Indeed, it's a good example on the rapid response mechanism, as you say, and you hinted towards it towards the end. In a way, we were lucky because we had a analytical method, right? It would be interesting to maybe to talk a bit how that was developed. Was that developed with detecting more phthalates in mind, or I mean, that's maybe one question. The second one, of course, is, as you said yourself, there were already phthalate studies planned. Imagine we, as ECHA, we would launch a question on an exotic molecule, right? That we would need to deal with, let's say, restrictions. Looking to colleagues here in the room. How feasible then would the rapid response mechanism still be? And maybe a detail for the audience that people who don't know. So PARC is co-funded, and on average, that means that for every euro a member state puts on the table, the EU puts the same and adds to that. Now, for the analytical methods, I've understood that it often is so that member states put 70% on the table and get only 30% co-funded. I mean, depends on the situation. So PARC seems to be having a lot of money, but there is a lot of kind of weighing on how much worthwhile is it for a member state to do that activity, and member states in general. Now, rapid response mechanisms have 100% funding for, at least for the part that the rapid response mechanism is. So sorry, that's a long talk, but it maybe gives some context for people here internally that if there would not be a test method, an analytical method available, and if there would need to be a rapid response, I mean, is PARC sufficiently able to do that in, let's say, a short time of a year, for example? Or what's your feeling on that?
Let's say, I think I start with the second question because it's a little bit more specific and also like in part answers the first question. So method development is, and this is like on the basis that everything works out. I usually would approach it with to have a validated method. You need 2 or 3 years when you start from zero. When you have a method for like a similar compound and you want to add something also, then it can be done faster. But so since you need a general answer, I personally wouldn't expect a feasible solution in under, let's say, 2 years, and this is on the basis of you get a complete financing of the method development and whatnot, and no problems while developing the method. So, and maybe just to put this in a framework, and this is the answer for the first question. So it'll be a combined answer. The method development of this multi-method for phthalate metabolites, we at the German Environment Agency contracted the laboratory of Holger Koch already in 2017 on the basis of the HBM4U prioritization. So, and there, like this, so we had a project where we said in HBM4U, we had the big prioritization list of, again, like phthalates as such, and they were categorized in different categories based in part on also on relevance of exposure, because again, we wanted to provide like a harmonized data set. And so we said it would be nice to use this multi-method that is already available and add also like highly regulated compounds. And at that time, in a part, the idea was as a proof of concept to just say, yeah, and we are looking for hexyl phthalate and we don't find anything, because why would we? So it's a coincidence on the one hand that we already had the method, we had the idea behind it. But so we started that project in 2017, and that's the reason why I come to the 3 years. The method was finalized in 2020. We also have, and this is something I didn't talk about, a method for human biomonitoring of this UV filter. So for us as human biomonitoring specialists, this topic, it blows my mind what like the coincidences, which coincidences build upon each other, because we have the phthalate method, and we have since 2019 a method for this UV filter, not because of all this talk we have now, but just because, hey, it's a new UV filter. It's like they really want to sell it because some of the UV filters are bad for the environment and are also like discussed reprotoxicants or anything. So we in human biomonitoring work with these substances to look into the substitutes. So now we can take all this and talk about it. But these all had like ongoing research questions and took some time to finalize and to get this data. So to have this condensed evaluation of the market and everything, this is like a wondrous thing for me that this all works out. Where I don't want to say that this cannot happen again, but, and this is now again like the second question you had concerning like the worst case scenario, you find a substance where you have like the toxicological relevance or whatnot, to say it is really important now to find out what is the exposure in Europe when the starting point would be year zero, no information about anything. I I can't say if PARC would even be the right project to address it, because I don't really know if considering the human biomonitoring, the idea of having new methods developed would be considered as a part of PARC. That would be like a question for the coordination team. But like in general, just looking into the time frame, I would have said it's at least not realistically to have a similar data set at the end of PARC. But like from the time frame itself, because it would be 3 years, you would maybe have a method and you could maybe implement it in some samples at the end of the project. Yeah.
Thanks. Very clear. Thanks.
Yes, Fleur?
Yes, thank you very much, Till. This was really, really good, and also very good indeed how you concluded the different optimum parts of this research, and how in the future we may have to temper our expectations a little. I think building up on what Wim also already asked you. So when in ECHA we would be looking for sort of new rapid response projects, would it be advisable to have a first screen through the type of projects that are already ongoing in PARC to get an understanding or to use our understanding of the ongoing projects to see how a new question from our side could fit to those projects, and in case it's really outside scope, to not try it out? Or do you have any view on that?
Before I answer your questions, I would like to at least considering the So what I wanted to say is regarding your comment on tempering the expectations. I really don't want to do it in that way. I just want to maybe more provide the understanding that we need the general prioritization processes need to be in some way harmonized, so that we land with the next problem in the same way we landed with this problem. So when we know we have substance groups which could be relevant in the future, it would be good to start working on them now, because if there would be like a prioritization, when you come to me now with a problem, I proposedly cannot fix it when I never heard of the substance. So this is just, so in general, I hope that all the next problems will fit into the same range, that we can say, yeah, we knew that there would come up something sometime, so we are prepared. So this is like the one part. Your other question, let's say I can just say it also just from my perspective. I'd say the feasibility of your request is definitely higher when you already approach the aspect with the knowledge of what priorities are already there in PARC. That you can that it's more about shifting or specifying work which is also already ongoing. But on the other hand, and this is something that Wim already said, there is a budget especially appropriated for the work in the rapid response mechanisms. So now for this project, for this piece of information itself, we did not go to this budget that much, because the topic was so fitting so nicely into PARC itself, so that it was not, because this is in the end again a financing issue. When there is already ongoing work in the aligned studies, and they say we will finance this amount of phthalate measurements, and now we want to have like one metabolite extra, and we want 100% funding for this one metabolite. You cannot calculate this. But so if you have now a complete new request, there is a part of budget which is set aside to also start complete new things where there is no national funding needed. How this is in the end feasible depends completely on the request. But I think still both approaches are fine. But I think like considering fast, quickly needed data and quickly needed like structures to work with, then an approach which targets some work which is already done in PARC directly is, I would say, more feasible and more success oriented.
Super, thank you. I have another question. If there's nobody from the room, is that okay, Safia? Yeah, good.
Yeah.
No, I was wondering because so thanks by the way for the answer. Really, really good also to have the nuances there, and I'll take them. I was wondering because you talk a lot about data generation and filling data gaps. What if we would be really in need of a method development? Would that be something for the rapid response mechanism, or would that be too big?
I do think that this could be answered through the rapid response mechanism, because I mean, in the end, all the experts or the connected experts are in PARC regarding like human biomonitoring and environmental monitoring. I mean, it depends on the general question. I do think that, I mean, like because the time frame still would be there, that it could be feasible. The interpretation, if it would fit into like the scope of PARC, I cannot give to you. So in general, it still is in the topic. I don't know how like strict the definition of the scope of PARC is on that regard. So I don't know if anyone from the coordination team is here who could add on that, but yeah, I think this completely depends on the question.
Yeah. Okay, thank you, Till. I'm checking if there is a question online. Martin, yes.
Yes, thank you. My name is Maarten Roggeman. I'm acting team leader for restriction dossier preparation in ECHA. Thanks a lot, Till. Very interesting, very useful for us to hear this outcome. A question a bit more specific to the actual case, so maybe less related to the mechanism. It seems, I mean, there was this initial thinking that cosmetics and sun cream use was at the base of what you see in the biomonitoring. It seems to be more confirmed now following your work. What is your feeling, from 0 to 100? Let's say what is the certainty that what you see is explained by the use of sunscreens, because there was indeed also some discussion, imports of articles containing these substances could be a potential source, possibly other substances. You mentioned exposure from house dust. I'm also thinking about the seasonal pattern. There could be, I mean, we know there's a lot of inflatable articles being used in the summer that may contribute to exposure potentially. What's your feel based on what you have assessed up till now?
So there is like one puzzle piece missing, and I talked to the scientists who are working on that, and we are hoping that like in the next 2 to 3 months that the data is available considering like the correlation of sunscreen use in a direct experiment and the exposure levels acquired through this. So just really like extreme and or like typical use scenarios for sunscreen, which have the highest values of the highest amount of these UV filter, and thus should have the highest amounts of contamination. Because in parallel, this is like the additional info just for the people around. The UV filters are not only used in sunscreen products, but also like in general cosmetics. If you start looking at it, you will see them everywhere. So also like in normal day creams, not specifically sold as sun protection agents. Based on the information I have from personal communication, I think, I'd say 90-95% that we will be really sure that it's the sunscreen and that it's nothing else. But as always, I won't say 100 because it always can happen something else. But I think all the data points in the direction that it's like the use will lead to the exposure we see. We are also working in our group on some historical data through the Environmental Specimen Bank, and hope that we will be able to see if there is something like the possibility of legacy exposure, just considering the use, if there even is something like a hexyl phthalate, which was used, which is always like when we are talking about import export, like what is unregulated, not from the EU, what could enter the market. And so sometimes it's nice to see if there were like old use cases in Europe. But I am currently at, as I said, at like 90 to 95. And I think the information we will get in the next half year based on the personal studies will lead to us saying that it is the only source.
And I think Mikko?
Yes, so I'm Mikko from ECHA's communication, and I would also like to zoom out a little bit from this scientific angle and ask maybe more related to my work as a communication and my colleagues. So first of all, how serious was the original exposure, especially regarding the kids, which triggered this exercise? We also received some media questions after the first news in Germany and Denmark. And bridging from there, I would like to ask that, is there already, or will there be some sort of a criteria when this mechanism will be launched in the future? And what is expected outcome? So will there be like recommendations for new risk management measures or information to direct EU level enforcement activities if we identify the exposure, or maybe even advice to consumers if the findings give some evidence? And I would also like to know that how will you communicate these results? Will they be done by German authorities or PARC? Thanks.
Many combined questions. I start with the health evaluation of the data. So after because we got really much media attention in Germany about this topic as well, and the general question, as always, with the human biomonitoring data is, what does an exposure mean? And the German Human Biomonitoring Commission derived an HbM1 value, which is considered as the exposure above which health effects cannot be excluded. And now, so to be highly specific, the original exposure we found was under this HbM1 value, but now there are two values in the current in the current round of the KISA study, so the children in Western Germany, where two children are above, and there we would say, or the common communication here is, it has to be seen where the exposure comes from. Exposure sources have to be reduced. Samples have to be reanalyzed as well, but this is something we already did. But so this is a range where where we say there has to be an action to reduce exposure. And this is something we also communicate in that way, because we say we are in a safety level where we have to act and where we have to reduce the exposure. For the other samples, as far as I know, we do not have exceedances of the HbM1 value. So this is the one thing. To make it even more complicated, the groups of phthalates are one of the groups where the combined toxicity of different members of the groups is known. So although we have the one substance approach of toxicology and of risk assessment, we know that we have an exposure to different phthalates, and this is another phthalate on the big group and on the big mixture of phthalates where we see exposure. And for a fact, this is one regarding the reprotoxicity, which has the highest potency in comparison to all the other substances. So as a communication, and this leads to me, how do we communicate these results? In general, this is a success story, hopefully ending with the interpretation of the SCCS that this contamination is not allowed in a measurable amount in products. And I'm not firm enough in cosmetics regulation how fast this can be implemented, how fast these products could get from them, if this would even lead to current products being taken from the market or anything. And this again is a really complicated topic for science communication, because on the one hand we have chemical exposure, on the other hand we say it comes from sunscreen products, and sunscreen is we do not want to say anything against sunscreen, because you have to have UV filters, you have to have skin protection from the sun. So this is difficult to communicate, but the general thing is we say the exposure has to be reduced. There are other products you can use. The market has to be stocked with safe products. So the UV filter itself is safe. So it should still be used, and should be used because it's a broadband UVA filter, I think, which has big use and should be used, but so it should be used in a safe way. And this is, for us, is a success story for human biomonitoring, which we communicate as such. On the other hand, it is important to have the relevant communication for the toxicity and for the toxicological reaction, which is not always really easy, but which is also more like the regulatory topic of mixture assessment and of endocrine disrupting chemicals and everything. So this is, on the one hand, an easy story to communicate, and on the other hand, a really complicated story to communicate, as always. And maybe a short thing about the second part. So what is the outcome of the rapid response? So if there are if this is structured to be implemented in a solid time frame, as far as I know, there's no limit on requests that can be taken. So as soon as there is the need and the idea for the urgent request, this request can be taken up from the agencies, and this request can be given to PARC. And considering your work for communication, I also think that the request itself can propose some solutions. And when the request would, for example, say there is a topic where there is limited information available, and we think this is a topic PARC should work on and could work on, then in the end also like communication materials could be a product of a PARC Rapid Response Mechanism. Regarding this project now and the MNXP, all the data and all the evaluation will be put into like deliverables that will be openly available because it is a part of PARC. So at the end of PARC, this will be all connected. In this month, or let's say that in the beginning of April, there will be like the first report of all what I presented today, which will be handed to ECHA and EEA as part of the rapid response as such, because we said we wanted to give all the data we have, all the evaluation we have at the end of March for the regulators to use in the potential proposals. Although, as you all saw, like the regulation itself is now more on the cosmetics side. And so this is all, this will be all a part of PARC. And I'm currently, and this is just like the last part of the product, considering the report we are doing now. I'm not quite sure yet if this will also be like openly available, or if this will just be, this is the data set we have up until now and we want to communicate it as fast as possible. But we will also see if this part can be communicated through PARC openly and publicly.
I don't know if there is any other question. I don't see online or in the room. So, well, I think we can again thank you, Till, for the very nice presentation and the updates. Yeah, and thank you all for your attention. And see you at the next science seminar. And Till, see you next week for the PARC meeting.
Yeah, looking forward to that.
Okay. Have a good afternoon, everyone.